Alright, these are your postulates for section 2.4 and 2.5. There are going to be 7 postulates and 1 theorem, so you need to make sure that as we're going through these, you fill them out on your theorem and postulate sheet. And you can only write on that theorem and postulate sheet what I put on the paper here through the video. If you have anything other than that, you won't be able to use it on your test. So make sure you're putting exactly what we've got down on here, and then if we need to add anything, we can do that in class. But I will check it before your test to make sure that you've only got what we've written down on the video here. Okay, first one, postulate 2.1 says through any two, okay, so fill in your blank, through any 2 points, there is exactly 1 line. Now there's a spot for a picture on your sheet there. You need to start out with 2 points, and that's good. We're going to make a note over here that we are starting out with points, and then from those 2 points, we're going to make a line. So that's what I've got up here underneath our theorem, or underneath our postulate, sorry. We start out with points, and we're going to go to a line. So we got points A and B. We're going to connect those two, and we can make line AB or line BA. Alright, now that's just one line. There's 2 different names here, okay? 2 different names, but they are the same line, okay? We've only got one line. Now, it's not going to curve back around like this. That's not going to happen, okay? So, no to that. That's a curve. Lines need to be straight, and there's only one line that's going to go through those 2 points. Our next one, postulate 2.2, says through any, this should be 3 points not on the same line, there is exactly 1 plane. Alright? Through any 3 points not on the same line, and remember, not on the same line, we could say non-collinear. Okay? There is exactly 1 plane. So if we look for our picture down here, we've got 3 points, and those 3 points are all contained in a plane. And we show a plane by putting a parallelogram, and we've got those 3 points inside, and we name a parallelogram with a capital cursive letter. So over here underneath, I'm going to do the same thing I did for postulate 2.1. We're going from points to a plane here. Okay, and it's important you know that. I'm starting with 3 non-collinear points, and those 3 non-collinear points are in 1 plane. Now, both of those are things that you should already know. Remember that postulates are ideas, basic ideas of geometry, and they're things that we should already know that we can probably figure out, but we don't need to prove them, so none of these things need to be proved here. We're going to assume that they're all true. Next one, postulate 2.3. A line contains at least 2 points. Okay, a line contains at least 2 points. Now it's kind of similar to postulate 2.1, but in 2.1 we went from points to a line. In 2.3 we're starting with a line, and if we have that line, that means we know that there's at least 2 points on it. We could have more than 2 points, but there's at least 2 points in that line. So we're starting with a line here. I can put 2 points on there to make those points X and Y. Alright, so we started with our line, and then from that line we add 2 points to it. And again, I could add more. I could add 50, I could add 100. Lines go on forever, so I could put as many as I wanted on there, but it has to have at least 2. Postulate 2.4 says a plane contains at least 3 points not on the same line. Now postulate 2.4, very similar to 2.2, they're just switched around. Okay? For 2.4, we are starting with the plane, and then we're getting the points. In 2.2, we started with the points and we went to a plane. So they are, remember when we flipped that around, we talked about conditional statements before. These first 4 are all conditional statements. They are all converses of each other. 2.1 and 2.3 are converses, and then 2.2 and 2.4 are converses. Alright, so let's finish 2.4. A plane contains at least 3 points not on the same line. So we got the plane, we have plane L, that means inside here I have 3 non-collinear points, and I made those points A, B, and C. Alright, that's postulate 2.4. we're going to go on now to postulate 2.5. Now 2.5 is different. It's not a converse of anything. It says, if 2 points lie in a plane, then the entire line containing those points lies in the same plane. Okay, I'll read it again because that was kind of choppy. If 2 points lie in a plane, then the entire line containing those 2 points lie in a plane. So here we've got our plane, and we have 2 points inside the plane. And what this postulate says is that that whole line also needs to be in the plane. So over here I'm going to put line AB must also be in plane L. Okay, since A and B are both in there, line AB has to be in there. Postulate 2.6 says, if 2 lines intersect, then their intersection is exactly 1 point. Okay, if 2 lines intersect, then their intersection is exactly 1 point. So let's draw 2 lines. We're going to draw them so that they intersect. Let's make this line L and this line M. Notice they meet right there. Okay, 1 point. We're going to make that point O. Now this will not happen. There's my line. Let's make this line N. We won't have a line like this that comes around and intersects at 3 different times. Okay? That's a curve. It's not a straight line. So this will not happen. But if they do intersect, and again they don't have to, they may not, you should know what that's called, that's parallel. But if they do intersect and they do meet, they're going to intersect at 1 point, only 1 point. Postulate 2.7, if 2 planes intersect, then their intersection is a line. And we've already talked about this. I'm going to draw a box here. And we've talked in class that every side, we could represent, use a box to represent 6 planes. Okay, top, a bottom, left to right, and a front and a back. Now in this particular picture, you can only see the top, which I'm going to shade, the front, and then the right, your right, of the figure. Now if 2 planes meet, which would be what 2 sides of our box, they're going to meet at a line. Okay, and that's postulate 2.7. If 2 planes intersect, then their intersection is a line. Now again, they may not intersect. We could have parallel planes like the top and the bottom of the box. But if they do meet, they're going to meet in 1 line. Okay, the last one, and this one's different, so make sure you find a different spot for it on your theorem and postulate sheet. This is the midpoint theorem, which is theorem 2.1. So located on your sheet, go find your theorems. It's the first theorem. It says, if M is the midpoint of line segment AB, then line segment AM is congruent to line segment MB. So down here for our picture, I've got A and B, line segment AB, they're my endpoints. M is in the middle somewhere, but in order to use this, I need to know that M is the midpoint. I rewrote that wrong. M is the midpoint of AB. Okay? I have to know this first in order to use this theorem. So somewhere along the lines it needs to tell me that M is the midpoint. And then if I know that, then I know AM is congruent to MB. And this is how we would write that. AM is congruent to MB. And then remember, congruent things have the same measure, so they are equal to each other. So I know AM is equal to AB. The measure of AM is equal to the measure of AB. They would have the same value. Alright, those are all your theorems and your postulates that we're going to look at today. There were 7 postulates and 1 theorem, so if you missed any of them, make sure you go back and you add your picture and you filled in all of the blanks. And you've only got written down what we've put on our sheet here. Alright? There you go.